Hello there, welcome to another problem session. So these are the problems we are doing from the JEE exam in India. This 2024 exam. Okay, and it's paper one. Um, okay, so let's see. This is actually a very interesting problem. All right, um, and I've given this problem various version of this problem in my test. So there are these two tanks, and both are gonna have a tiny hole. They can both fill to the same. So let's look at the side by side. But this tank will have opening extended all the way down here. Okay, so they're the same height, starting height. Okay, to empty this takes time t1, and empty this times take t2, and so we're supposed to figure out that what's the value of t1 over t2 given other conditions, right? So building is height h. So the top building height h are filled, and these heights are both h initially. Okay, so we need to figure out a way. Yeah, there's also these things. H is 16 over 9 h. This is chosen so that this ratio is actually turns out to be an integer. Okay, how do we figure out this? Well, we need to know how fast this is going. So at some time, some instant t, this will be at this place, and the water will be moving some speed v. Okay, v prime, and we need to actually monitor the height. So we will say, let's call this y-axis, and this is y. And so if this is going down, let the speed be velocity which would this surface is coming down, this vy in this case. So we need to actually apply Bernoulli principle in this for this point and this point in the motion of this fluid, and that will give one condition. Another condition will come from amount of fluid that this flows in small amount of time is the amount of fluid will flow over here. So there are two conditions. So from Bernoulli, let's see, so it's at plus point A and this is point B. In point A, you can see the pressure A is osmotic pressure. So pressure at A plus half rho is same density. So rho V at A square plus this height rho G Y of A, that should equals to pressure at B plus half rho V at B square plus rho G times is 0. For this problem over here it will be a little different, but over here is 0 reference. Okay, this is atmospheric pressure. So this is equal to atmospheric pressure, this atmospheric pressure, and they will cancel out. This of course went away. Another thing you would notice that V at A, we are assuming that this area, let's call it script A, is much bigger than this area, let's call it little a. So since script A is much bigger than little a, we expect VA to be much less than VB. So in the same expression, I'm adding these two or subtracting one from the other, and one is very small compared to the other, so we can just ignore this, ignore this equation. So the VB simply turns out to be square root of solving this gives me 2GY. YA is simply Y. But this alone doesn't give me a way to actually find the time. We need to figure out another formula where I can get an expression for VA. That's going to be VY. So what we say is the amount of water that's flowing here, so this area of this thing times VY must be equals to this area A times V at B. And Vy we can write down as dy over dt. So we have the area dy over dt is another area, and this Vb is the square root of 2gy. And let's see, this dy over dt is from the way it's written down should be negative, so this whole thing is positive and this whole thing is positive. So dy over square root of y equals to minus a square root of 2g over script a. And so I need to integrate from y equals to little h to y equal to 0, little h to y equal to 0. That will and on the other side will be dt, and integrate 0 to t1. Okay. Okay, so I took a liberty of pausing the video and carrying out this calculation. So from here you can see I can just simplify it and just integrate this out, and the other side can be integrated, and I do get minus sign appropriately here and minus sign appropriately here. I can solve it for this, and you can see that in the final answer this this factor here won't matter, right? Because what I'm interested in the ratio. So I can just leave it here, and later on we'll cancel out. Okay, let me pause the video and clean up and try to do this part. It's going to be almost identical to that. All right. Okay, so I clean up, and you can see now if you work out the axis at some arbitrary time t. So here is, in this case, again I do the y-axis like that. So arbitrary time t, and this some point A, and now the point B is down here. Everything is identical to that, except that point B is going to have YB will be not 0. This will be the same. This is atmospheric pressure. It's pushing down on it. It's pushing against atmospheric pressure. So P0, P0. So it will look like P0 plus half rho Vy squared over for that plus rho Gy equal to P0 plus half rho over here VV square. Then it's going to be rho G, and the y of B will be minus h. This is 0, and then this kind of negative. So minus h. So now it's just, you can see this cancel, and this I can ignore again for the same reason I did over here. So VB is actually square root of 2gy plus h. H is constant, so it's just displaced by h. Is going to be almost identical to this answer, right? And then this will be very similar. It's going to be area A dy dt minus dy dt will be equal to a square root of 2gy plus h. And so here the integration will be dy over square root of y plus h. And again, I'm going to go from h to 0 for the emptying of the tank. And the other side will be minus a over script a square root of 2g, exactly same thing as before, t2. So this is the integrals I have to do, okay? And if you had everything from the before, you would have done it. Let me pause it and do the integral again. Right. Okay, so I went ahead and did the integral, and you can see just like a displacement I had talked about, it's going to just displace a little bit. Now the ratio, we can definitely work out T1 over T2. This whole thing, garbage thing, will cancel out, and you get this. Now over here it says you can take h over h to be 16 over 9, which means I can just go out and divide by h everywhere. So you have 1 and square root of h over h, h over little h plus 1 is square root of h over little h. And so let's do this 1 over, and this is going to be 16 over 9. Oh, let me and plus 1 minus 4 over 3, and that's 1 over 5 over 3 minus 4 over 3, and that's equal to 3. So that's the answer for this. Okay. Now actually a lot of algebra here, but you could very quickly simplify it. If you're in a hurry, you can actually see that this, I didn't have to write the whole damn thing, and I didn't rewrite the whole thing. I would have known that this will be this right away. So like getting this answer, you could have done it just from the memory of how these kind of problems go. And so all you have to do is set up this equation and then just solve it. So that's how I would do it in a hurry. But it's good to know where they come from. And so in the future, if the problem is a little bit modified, you can actually attack it. Okay, so that's it. I'll see you in another video. Bye.